How about this one works too? Try this one. Well, the light that is on, when you turn it on, doesn't go on. So if you put it in, it's
all right. Cool, well, let's get back to it. By way of introduction, my name is Ryan Rawson. I've been working on HBase for 5.5 years. Ever since January 2009. Back then, I worked for a company called StumbleUpon in San Francisco. Let's get those levels up. Worked for a company in San Francisco called StumbleUpon, and they were like, well, you know, looking at our projected user growth and how much our existing database infrastructure scales with the users, this is just not gonna, this is not gonna scale. So we need a better solution. And one of my colleagues was like, well, hey, you used to work at Google, which I did. I don't admit that too often. They have like that big table thing. Can't we do a big table thing? So I'm like, yeah, that's a great idea. Let's survey the field out there, because writing a database from scratch is pretty hard, and why not leverage someone else's work? So looking in the space, the NoSQL space in early 2009 was completely different than it is today. Most of the top players either didn't exist or were so uncredible that they were just crazy pants. Cassandra had like a hard baked-in requirement on Java 7 in 2009, and that was not really feasible then. And it was all these wacky things. And HBase turned out to be sort of the best looking of all the projects. One of the big things when you buy into an open source project is you're not buying into just so much the code, but the entire community around the project as well. Right? Like, what's the viability of the community? How easy is it to work with? How can you get fixes in? All that sort of stuff. These are all really sort of important decisions to make. Not too unlike, it's like the parallel of assessing a vendor when you want to buy from a vendor or start becoming dependent on them. So we started building out a HBase strategy at StumbleUpon, worked through that, ended up hiring Michael Stack, the project chair, and some other committers, and built up a HBase team at StumbleUpon. There's a little snag in that whole thing, is that the projected user growth fell short. So the stuff was useful, but not super critical, not like a Dropbox. Eventually I left, and the HBase StumbleUpon team got bought out by Cloudera. There was like some kind of tricky transaction thing, and I've gone on to do other HBase related startups with Alex and work at WANdisco with him now, with everyone else there too. So that's sort of like my background, how long I've been working on this stuff, for too long probably, I guess. To recap sort of the use cases, I know this is my recap of his use cases. So these all revolve around real-time access to big data. Essentially, if you don't have big data, you probably don't have HBase. And so it just doesn't make sense to use this kind of technology in something that doesn't need as many, mostly because HBase runs best on like 10, 20, and up machines. So if you don't have a data problem that requires a dozen machines, then you probably don't have an HBase problem. A lot of this stuff revolves around log analytics. One of the nuances of the BrightRoll use case, which I find really fascinating, is that they have a very large amount of web servers that do a large amount of different things. And they serve the ad, they serve beacons, they collect data, but this data is actually separate among dozens, if not even hundreds of log files, and they have to centralize it. And a lot of ad systems have this kind of problem. So doing log analytics is a big deal. Pulling things together into a single place. This is something that HBase does really well. The standard kind of MapReduce paradigm involves like having giant logs, and then running MapReduce on them, and then magic comes out the whatever, like information comes out the other side. And the other big deal is archival and historical data that just cannot fit into any other system other than to something the size of HBase. And then really tying all that together, real-time access to all of that stuff as well. So if you don't have real-time access, people usually opt to just stick with MapReduce. Oh, that's good enough. But people are finding that you can't just be stuck in a world of MapReduce. So to kind of talk about the challenges of running HBase for reals, I sort of created this little pyramid kind of paralleling the Maslow's hierarchy of needs. There's really this hierarchy of latency events that cause outage and downtime. Just like sort of the real pyramid, people start at the bottom, like, okay, I can't work on anything until I, have food. I can't work on food, I got food, I got shelter, and you build your way up. In the same way, at the very bottom are these tiny little events. This is the first thing people notice is like, oh, I have all these little pauses, just like the unnamed social network is like, oh, I'm having the 1 second pauses. That's a big challenge, oftentimes due to misconfiguration of garbage collection or even like just I/O overload. Systems can't respond in time. The next step is sort of 1 to 10 second impact things that just are little. And there's a lot of GC problems in this area as well. The Mondo super huge garbage collections that take your system out for 10 seconds is not super fun to deal with, and oftentimes a little harder to diagnose. It's like, okay, what's going on? I haven't figured it out. And moving beyond that, once you've gotten your system up and running, okay, maybe I have my things tuned, everything's a little bit better. Then you have a node outage. That's the next thing that you have, and you're like, oh my god, this really sucks. It took my systems like 5 minutes to come back online or whatever. Just recovering from node outage is a big problem. And then finally, this is the self-actualization areas. These outages have extremely large scale impacts. These are rack level outages or data center outages. You've made the big times when this is where you're worried about. This is I wouldn't say great place to be because there's not a lot of super great solutions for it, but maybe you conquered the rest of the pyramid at that point. And really these events happen way more frequently than you would ever think. They basically range from literally thousands a year to like somewhere between a half to 1 a year. Starting at sort of like the largest scale data center failures is a big deal. It happens a lot. Amazon EC2 and EBS and all those systems typically fail once a year, once every other year. Google has a really great talk entitled something like "That Couldn't Happen to Us, Could It?" where they detail all the failure cases that they see, and essentially within the first year of rolling out a new data center, they expect to see the whole thing fail by some mechanism. Usually like backup power that wasn't, fancy flywheel systems that didn't, fiber optics that wasn't, just all these sorts of things. Oh, surely no one could ever, backhoeing through a fiber optics cable is totally cool. Like, that's expected, but how about like hunters shooting down like fiber optic cable? Totally happens. And just in general, even once you get past that, the wide area network is really cruel. There's, you have to compete with everyone else for bandwidth, and that means packet loss. Nodes fail, nodes love to fail. Even in the local area network, you can also still be contending. Switch bandwidth is not infinite, and someone loses eventually, and that, by, what is that? Anyways, it's going to be you at some point for sure. And then just the mundane things like processes crash, you found a new bug, or some other weird kernel thing, garbage collection, total pain, and just like I/O blocking. All this stuff causes huge challenges. But this is sort of like the the why, and there's sort of like why is HBase particularly challenging, and what why does it take Facebook literally a dozen of like committers and top engineers, people that could work, people who work at Facebook could probably work anywhere they wanted to. So they're working at Facebook, and here they are running basically just Facebook messages. And these problems, the first one, and this is the one we've really struggled with, is there's just too many parts. A standard HBase installation has at least 2 parts that are deployed in different configurations. And then once you've deployed HBase, you have to have HDFS to deploy on top of, and that has a number of different things. And they have like an asymmetrical installation problem. So some nodes get this one, and other nodes get that one, and all this kind of stuff. I've sort of thought in the past, like, oh, some kind of node layout thing would be really good, but I've never seen one that I love, and I've never been able to write one that I love. And the big problem is each one of these systems exhibits their own asymmetric, completely different scalability challenges, right? So Zookeeper scales in its own specific way. Named node scales in its own specific way. It needs its own special nodes, oftentimes, with more memory. And HBase has its own kinds of nodes, and you need different amount of disks. And there's best practices that say you should use dedicated I/O paths for Zookeeper, not even just disks, I/O paths. All this stuff just basically, when pulled together, you have to deploy something like, I don't know, 17 daemons or something like that. I think it was 16. It's insurmountable. And usually people get past this. When you really need it to work, people make it happen, and then those people leave, and then the new person looks like this, because they have no idea what's going on. There's also another kind of dark side. The configuration is like way out of control. For a full system, you're talking about configuring multiple systems. There's like 20 files, hundreds of configuration options. It's just kind of just crazy. And the big problem is understanding which ones have a high impact and which ones are basically almost ignorable. And that's tricky. And without experience, you generally don't really find out about this until you get to workload tuning. And this is where life gets very interesting. As workload tuning, I think there's sort of two elements to it. The first element is that garbage collection tuning, is a big deal. And this is actually like a real garbage collection visualization. The problem is that no one really wants to become experts in garbage collection tuning. You're like, okay, I have a problem to solve, and the problem is technically not garbage collection tuning. But you still have to solve it, because otherwise it's gonna hold you back. But even just beyond tuning that, there's lots of other tunables. How does HBase impact your I/O? There's a whole compaction series of tuning. And really the big problem with this is that it's workload specific. And Brightroll specifically, they got things going, and they're like, oh great, the system is working, and then let's use it some more. And then the workload actually causes the workload to shift outside the tunability parameters. It's like, well, a successful system, and then it becomes more successful, then fails. And this is common in other systems, but this is not absolutely required. So just a pain. And this one is really kind of a wacky one, but developer complexity is just too high. The build takes too long, tests don't always pass. These sort of things are kind of semi-abstract, but they really stand in the way of quality. And I've watched enough projects not succeed because of quality that I determined not to let that happen to my projects. So this is a big problem as well. So the next one here, the next big challenge is something we sort of dubbed this WAN availability problem. And HBase doesn't ship with a lot of great solutions out of the box. HBase has a replication system that kind of resembles MySQL replication, where a write-ahead log is made on one machine and then it's copied to another and then it's applied. But that's just that's not really a solution as per se. And from talking to people who should know better, they've said that this stuff is not easy to make consistent snapshots. We try to use it to make a consistent replica, it's just not working. And then the next level of challenge is, even if it did work, how would you know for sure it was working? Verification, none of these tools are sort of tied together. This is sort of a big problem. If you're just walking off the street and you're saying, well, let's just use this, and I got 2 data centers, and I see this all the time with users, it's, instead of providing a solution either in the open source, even in any vendor, instead you're just faced with a series of small grain tools that will sort of help you kind of solve the problem, but not really, you still have to put it together yourself. So the big question is, how do we fix this stuff? And we really need to fix this stuff. This technology is really important, and we can't just say, well, I guess we're good enough, I'll go home. Here there's a new release of a favorite video game of mine or whatever. And really, I've separated our fixes into 2 major categories. The first one is the fixes that will be done in open source and will benefit everyone who uses HBase. These ones are super exciting. They mostly cover the center part here. And what are they? So the first one, and I put this one, I led with the least exciting one because I led with the one that you guys are most excited about. Alex is most excited about. Just generally, in your own processes, if you think about what makes a mature software project, continuous integration, build that passes, having a full automated loop cycle, improving that, tightening it up. Right now my CI system tells me it takes 7.5 hours to unsuccessfully complete a build. you know, some test failed. I don't know. Why did the test fail? I think I ran out of memory. Got to nail this stuff down, right? If a test fails because you committed, if the tests aren't always reliably green, you got a problem. HBase doesn't know that right now. And also tests just, you know, 7.5 hours of tests is a lot of tests. You know, how confident are you in the system now that those tests run? I don't know, maybe good, maybe bad, but you know, you can always do a better job testing. And really for something that is so widely used like HBase, you know, testing is just absolutely essential. And I heard these guys did something called test-driven development that improves tests or whatever. Maybe they know something that we don't. We can, you know, do something that. But more importantly, just as importantly, you know, one of the big cornerstones is bringing a Raft implementation to HBase. So about 1.5 years ago, this guy from Stanford, he's officially smart because he got his PhD, and you know, I did not. So he wrote this paper. It described a replication system called Raft. You know, we wrote one at Data. This is going, you know, into HBase eventually. You know, don't exactly know when. You know, it's a big change. Getting big changes into open source things is you know, just not overnight. And the big key takeaways here is, you know, this will really enable a faster failover. So when nodes fail, we'll be able to recover and switch over to a new node, you know, within some much shorter time frame rather than the multi-minute story that's going on right now. And really, we're hoping this is going to enable also less moving parts. You know, the solution to a complicated system isn't to add a management layer to deal with that complexity, because now you have a new problem, and that's the management layer is also complicated. Instead, you strip away complexity, you remove parts. This is our attempt to do that. We're also working on another series of things that abstract away the use of something called Zookeeper, which most of you have probably heard of. The problem is that the way that HBase uses Zookeeper is not ideal, and it's all very confusing. Simplifying the code base, making it, you know, the simple thing that can't fail is always the best one. So I feel like there's some really good analogies in, like, you know, bolts and nuts and stuff, but I can't figure it out right now. So that's the open source side, but there's still kind of this top and bottom space. It's really tough to tackle. You know, each one of these slices requires a completely different type of strategy to attack. Some are best done in the open, and some are best not so in the open. And our fixes are kind of around two levels: one to attack the bottom and one to attack the top part. On the bottom part, to attack sort of the small, you know, the small pauses, the 0 to 1 second-ish pauses. And the first thing we do when we walk into, you know, a customer with a difficult use case is we show up and we're like, okay, nice cluster, give us all the information about it. And surprisingly enough, getting the full information from a cluster, like, it's tough. People don't know how many disks they're running or how many CPUs they think they are not running in memory. And then there's the configuration, then there's the logs. Just gathering that is, you know, support engineer tasks, very difficult. And then looking at that and saying, well, you know, what are you doing right? What are you doing wrong? Which areas can be done better? You know, no system, you know, a lot of customers we run into just are suffering from what could best be described as, you know, beginners types of problems, which they're beginners. Of course they're going to run into those problems. So this runs into something else super exciting: best practices management. Ooh, so cool. But, you know, when you show up and you have a problem, or a vendor shows up and like, okay, let's just fix the problem already. And then the last bit, which is a lot more exciting, is where we have this technology that's going to be able to solve the lowest latency events that no one really can, and really tighten things up. You know, HBase has always endeavored, I've always wanted to endeavor to attack the sub-millisecond range, and, you know, we got to get there, and you don't, you know, it's not free. It's tough. It's a really tough problem. So that's the low end, but really, let's, you know, the self-actualization will come at the end, you know, right where it belongs. You know, WAN availability is a huge problem. Right now, people run HBase and they really worry about, you know, something. They're worried about, you know, disaster recovery. What happens when my data center is lost? And, that's sort of a big deal. How do you run it? How do you run HBase across multiple data centers? All that kind of stuff. But really, we need to most of the most advanced companies no longer talk about disaster recovery, right? The disaster recovery is fine, but really you're talking about business continuity, website continuity. Just this thing, that you have, your service has to really survive, most feasible problems. And as we learned from, a year or two ago, hurricanes apparently do hit the Northeast and really, drown your data centers, and there'll surely be an earthquake around here at some point. I guess there was just one, but I missed it. So really, you need to reach across multiple data centers, get to 2 or more. Like Google, the gold standard for Google services is 5 now. They're a bunch of crazy guys. You really need to reach across multiple data centers. And really, part of the problem with doing that is that you've added. What's that?
Question.
Yeah. What's up?
HBase have data center application built in already?
Yeah. So the question was, doesn't HBase have some kind of asynchronous replication built in? And the answer is, it does, but it exists as a series of minor features and doesn't exist as a total package. And getting it to keep 2 clusters in sync, in synchronization, is very difficult, even if you have an inordinate amount of resources, which one of our potential customers has told us they could not get it to work. It just doesn't seem to work for them, and which surprised me since I thought it did work. So whatever.
So which feature? There are 3 options for that, right?
Mm-hmm.
Master slave, and cyclic or something. Can I take this one?
Sure.
Yeah, so I talked to these people, so I can give you a little bit more detail. This is. Let's see here. What can we say about them? They're one of the largest HBase clusters in the world. They have over-provisioned WANs, so they don't even have the problem of their WAN backing up for hours or so, which is actually pretty normal. And what they told me was, so at the end of our day, what my ops guy wants to do is he wants to be able to take a snapshot on each side and then verify the snapshots, right? And that snapshot can even be we even tried it when it was 4 hours old, right? So we're talking about something way more sophisticated here than that story. And we're talking, but that was something they couldn't get working. And this comes from people who know, no offense, but I think know more about HBase than anyone in the audience right now. And you guys have to solve this problem. And if they can't solve it, for us, the question is when we solve all of these kind of higher level things, when we get the latency down, this WAN availability story opens up and it becomes a whole next level thing. And what we're trying to do is not only provide the WAN replication story, but also verification. How do you know that your replicas are valid and up to date? How do you compare them? How do you actually validate it? And that's why I think this is similar to the story of HBase, but we decided it was valuable enough to solve with our own technology.
Yeah, well said. So I think that sort of covers the whole WAN availability thing. Really solving it right out of the box is something that is not there yet. So there's some challenges, some solutions, some opportunities. Why HBase? One of the big reasons why I got into the HBase space is that large-scale real-time web apps are really the next generation. This is important stuff, right? We're really now when I got into it 5 years ago, there was not that many of them. Google was sort of the poster child, and Dropbox didn't even really exist for most people. Now web apps, this is just how. This is the next generation of how how we are building out technology and scalable technology and all this stuff. And really the database at the lowest level is often the thing that holds everyone back. And it's a major problem. If you study what Twitter's been doing and what everyone else has been doing over the last number of years, I know everyone's keeping up with all that news. So they have spent an incredible amount of time and effort just making their systems run well, and it's a big deal. Now this stuff is really important, and these are just sort of the next steps of making this stuff great. You know, we need to really get to a really great place. You know, it's definitely doable. You know, but we really need your help. You know, just testing this stuff. You know, running it. You know, what are your real challenges? What are the problems that we really need to solve? Every time we talk to a person who uses HBase, either user, customer, or potential of either of these things, it's always surprising when people say, this is the most important thing for me right now. And you know, everyone has a different story there. So I'm really love to talk to you guys about this kind of stuff. So, you know, that's this presentation. So I think we're going to do some Q&A now and stuff. Tops. All right, front row.
All right. Can you comment on encryption, like encryption support in HBase, and also like if data masking also?
So the question was about encryption support, data masking, and HBase. This is really important. You know, one of the things that people discovered is that encrypting data at rest is oftentimes like absolutely critical. Hard drives walk out the door all the time. Data centers that are highly secure aren't. And not everyone is in a super highly secure data center. And just disposable hard drives becomes a big problem. This stuff needs to be baked in, it's not. You know, data masking. Again, one of the big problems is that we're still, I think, working out what are the common use cases? What do people care about? What kind of infrastructure should exist to do this? Obviously, encryption at rest is a big deal. Also, I think technology is still just catching up, right? Intel released AES encryption built into the chip only very recently, and I know Alex wants to say something about this.
Actually, this is there's been some cool things that HBase has done recently here. They have, I don't know if you've ever heard of the term transparent encryption. So HBase server just added a notion of transparent encryption based on AES. I just saw the Jira go in for actual HDFS transparent encryption, and these two things will add a lot of like the encryption at rest type capabilities. I think the encryption at transit stuff for like legit HIPAA compliance is still there's still some work that has to be done there. But a lot of these things can also be solved from a systems point of view. So, you know, I think that the HBase transparent encryption and the HDFS transparent encryption are a really powerful tool for users. But, you know, now we have drives that have some self-encryption capability at the BIOS level. IPsec's kind of like the go-to for data center level encryption. One of the things that we're looking at doing is actually building the next generation HBase RPC framework. Andrew Patel recently sent out sorry, for all of you guys don't know, Andrew Patel is also, he's been a committer as long as you, right?
Longer.
He's been even longer, yeah. And he's at Salesforce now. And he had this really cool thing where he's like, hey, let's rewrite the HBase RPC in Netty. And we were like, yeah, absolutely. By the way, we've already done that. So we're trying to show him some of the work we've done to do there. And the cool part about moving it over to Netty is one of the interesting troubles with encryption. Mind you, we should talk afterwards about this. I'd actually argue that AES and all contemporary encryption is basically nonsense, and unless you're using Galois counter transport, there's no real value. But because, you know, authentication versus encryption and all that stuff. But the nice part about when you move to Netty and new RPC procedures is you get HTTP. When you get HTTP, you get HTTPS. And HTTPS key management is like a solved problem, right? So I think that's part of it is, you know, we've kind of done that first effort in doing, you know, like transparent encryption HDFS, transparent encryption HBase. The next step is how do we hook in with all these security things that people already have? This is something that is kind of a larger point in the Hadoop ecosystem, is all this stuff was really designed to work at the largest companies, and I think a lot of companies have like their intrusion detection systems, their SSL terminators and all that stuff. And what would be really cool is if we could get the power of both of them, right? Where we could use all that existing technology. So I think you're going to see some cool stuff coming down the pipeline and transport. And there isn't a Hadoop encryption story in HBase. I haven't seen how good like Cloudera Manager and all that stuff makes running it. I don't know, maybe you might actually know.
Yeah, actually I was thinking about you going to comment on that, the Intel's Rhino project. I thought they commented something on HBase.
Yeah. Man, this, no, I mean, this is a really good thing. So, my basic problem, oh God, this is going to be so controversial, I'm going to say it anyway. My basic problem with all of the encryption stuff that we've seen going into the HBase projects recently is it's come at a cost of code complexity. And I think that the projects are going in the right way, but for me to really trust an encryption system, like they're solving some really gnarly problems. It's going to take me a while to buy that approach. But I mean, once again, right? Like there's management of your encrypted systems. There's the key management of your encryption systems. There's the encryption, the security capability itself. We're kind of eating around the edges. I think vendors are got to the point where they've solved some common use cases, but it still ain't pretty. And that's what I'm really looking forward to. Something that's a little bit prettier.
Yeah, what I understand is like Cloudera is charging a whole lot of money to, for the Cloudera manager.
Sentry is now open source, so there's at least an Apache Sentry thing that you could use. That's pretty good. But I mean, once again, like there's this expression, right? Like these really hard problems, everyone wants a silver bullet. Like now we got transparent encryption, right? We're solved, right? The reality is you don't solve these types of problems with silver bullets. You solve with 100 lead bullets that you're shooting constantly. So I think encryption and security will be always one of these things that we're iterating on. I mean, frankly, I think with these revelations we've seen with Snowden, AES encryption is useless, right? Like, depending on who your threat is, you need elliptic curve cryptography now. So I mean, and obviously, I can't hack an AES encryption thing, so it's not really useless. But you know what I'm saying? Like, these problems are never solved, and vendors like Cloudera, Hortonworks, Intel, they're going to be putting butt tons of work to continuously do it. I also am just looking super forward to actually tying into more hardware, like encryption-based hardware. One of the things we were doing at OwnData, since we could use SSL, and Java's got its own SSL implementations, you could actually use those hardware smart cards. I don't know if you guys remember that. I guess people probably use USB keys now.
Something like that.
Yeah.
I think from like a project management point of view, it's important to make your voice heard on what things you need. I need encryption. I need it to be simple because guess what? When encryption is too complicated, it gets fucked up. And when it gets fucked up, it just doesn't work. Yeah, PGP. You guys all use PGP. People use that for years, right? Or people have not been using it for years. Anyway, so really, get into the mailing lists. There's vendors out there if you care to engage with them. Say, hey, this is what I need problems with, and you can always, demand demand things out of people that isn't there. And if you're not, just for any feature in general, if you're not making your, needs heard, it just doesn't get done. And that's the thing about an open source project is that, there is a bunch of committers, but they're driving the project in the direction they think is important for their own needs. And all, let's face it, HBase, people thought of open source as like this. I just do it as a hobby. There's no committer who doesn't do it for a full-time job. They're getting paid buckso by someone to pursue their agenda that may not be your agenda. So making yourself heard is the first step. Anyways, there's a guy behind you that has a question.
Just want to go back to the topic of application. Actually, in the past years, I've been working with my customers. My customer always talk about data coverage, right? So the solution I get to them is, well, if you don't really need the data always sync to each other, that's the snapshot. And we have a solution with the snapshots and move data over, and we have something about the incremental backup. But if the customer wants to have close enough, but not totally synchronized, the master to slave replication is, I feel, is a pretty good solution. I haven't suggested my customer to do a very complex one, master, multi-master, multi-slave. I haven't go that far yet. It can be. But usually I say, okay, I understand master slave. I think that's good enough for next situation. So I kind of feel, I know it's not totally beautiful there, but I feel, thank you. So I feel the master-slave replication can satisfy a lot of user cases already. So that's why I can recommend to my customer.
Yeah, I would probably back up pretty much what you would say. I'm going to be a little bit more nuanced. So to restate what you were saying, and stop me if I'm not saying this is, so hey, maybe we'll give up a little bit on consistency. Doesn't HBase peer-to-peer replication support that? I'd also argue secondary region replicas are another one of these mechanisms. Can you do this timeline consistent thing within your database and raise your availability, raise your WAN availability. The P2P features of HBase, the peer-to-peer replication features, it's actually an amazing, it's an amazing feature, right? Like,
it's a technology piece, right?
Yeah, from a technology point of view, it's actually really great. I mean, master-master replication, end-to-end replication, so you can have a certain number of clusters on this side and a certain one on this side. There's a lot of really cool stuff going on. But the problem is, and we've seen this over and over again, and it gets better every day, right? We're talking about open source here. I mean, HBase is, as we pointed out, one of the most commonly used databases out there. There's tons of amazing work in it. HBase replication gets better every day. But from our point of view, it's still not addressing a lot of use cases that people have in terms of how they want consistency. I think part of this is just what people want out of a replication system, what people's DR requirements or business continuity requirements are actually different from company to company. So if you look at like Google, what they've done with Spanner, I mean, that's like super crazy, right? Like
5 replicas.
Yeah, 5 replicas over the WAN, fully consistent, Paxos and two-phase commit, doing both, ultra high latency and all that stuff. And that, I don't think anyone's saying like, let's do that, right? Like no one's calling out for like, what everyone needs is Spanner, right? Like I don't want to say that. But on the other hand, like I think of a lot of the users out there, and I say like, well, okay, are they going to fire up the shell and run the HBase replication commands, right? So maybe I take the really easy approach and I say, well, maybe I build them like a stupid screen so they can use the peer-to-peer replication and do it for them, right? But even then, how do they verify? How do they know that the data is exactly the same on each side? And the other half of it, which is really tricky, is, I mean, even today, actually even knowing how far behind a replica is actually kind of tricky, right? The metrics that it gives you only give you a certain level of detail. So I think that, the HBase peer-to-peer replication features is trying to solve a very broad set of approaches, right? As Ryan pointed out, built on MySQL log replication techniques. This technique is known to have a certain set of advantages and a certain set of disadvantages. We've chosen a different one. WANdisco has been building these kind of systems for a long time because it addresses the types of use cases that our customers had. I think that we'll continue to focus on improving the peer-to-peer replication features and also our own replication features. But for now, like Ryan keeps on saying, what do? Right? We talk to people. We don't try to judge anything, right? Like we both obviously love HBase. We contributed to it. But we're very honest about where we think what can be improved. And this is just something where someone said, hey, you know what? We pay you a bunch of money if you did this for us. So that's what we did. That's simple.
Yeah, I agree with you. And actually, I think you touch base a couple of things that replication don't have. One is need a kind of a manager node on top of that across the cluster. You mentioned a little bit about that.
Yeah.
Another is the control about the delta between the master and the slave.
Yeah.
And now you can tell it, but there's very limited you can do to deal with that situation, except wait.
Yeah, right.
With the quiet time.
Yeah.
So that's I totally agree with you.
We got some special tricks, some secret special tricks also to throw this problem.
It's not replicator solves that. I think someone behind.
Oh yeah.
Sure.
Yep.
Do you mind passing the?
Sure, go ahead.
Do you mind passing the?
We should
little
talk afterwards
mic?
though. That was a good thing to chat about.
Cool. Hey.
Yeah, I'm just interested in Zookeeper and wondering if you could share more of what you did. So did you reduce the services that were offered? Did you just move the management of within HBase?
Oh yeah, definitely. One of the big problems and one of the series of patches that we're addressing is that HBase uses Zookeeper for a bunch of different things. and uses it for cluster management, which is pretty good. That's what the use case is used for. But also uses it for handling the master and storing intermediate master state inside of Zookeeper. And this has turned out to be, this was supposed to be a solution to recovering masters, but what's ended up happening is that it's just become a level of complexity that is just kind of crazy pants. Because remember, every single time you're doing the master is doing an operation, right? It's opening a region, closing a region, moving things around. There's intermediate states, and this is you have to wait for something to happen, and then the master needs to do another thing, and all that intermediate state is stored in HBase, and all the code that addresses that is essentially done in an ad hoc manner. So when failover happens, the failover recovery is done in an ad hoc manner, and it's turned out to just be a little bit more difficult than people anticipated. It's literally taken years to get to a state where it is, not horrifyingly buggy. The first versions were just in text, and then they had the system exit call when you ran into something unexpected, and the master would quit, and then. Anyways, basically this problem is an incredibly difficult problem. We're introducing an entirely new strategy to kind of address this stuff. Basically, the problem is that Zookeeper is hooked into the stuff so deep that getting rid of it is almost impossible. We're introducing a new interface layer that will abstract it away and potentially allow the removal of Zookeeper in the future. Because right now, when you look at the code, it's there's no way we can remove Zookeeper. Absolutely no way. But my goal is to remove Zookeeper.
Yeah, we just pushed a patch, so now the client doesn't. I don't know if it's been pushed, but we put a patch up so the client doesn't have to know anything about Zookeeper.
It's still in code review, but the client no longer needs to connect to Zookeeper and can figure stuff out just from the cluster itself, rather than having to consult this other source. And this sounds sort of trivial, but one of the biggest things that HBase could really use is a client story in a different language, such as C. But when you have to talk to another system, such as Zookeeper, which has its own very complicated RPC system, you've just doubled or tripled your complexity. Let's make things simpler. One way to do it is to keep Zookeeper information out of the client, and all it really needs to do is figure out, hey, where's the first bootstrap process, and then I can do HBase stuff from then on in. So it's really getting at the smallest amount of data.
Yeah, and also I should mention the goal with this stuff is I push patches in Zookeeper. I think it's a great project. The goal is not to dump Zookeeper. It's hey, why not make it pluggable? If we can support any consensus protocol, there's a ton of Raft protocols that are going on the internet. If we can support any of these and build a high quality one, we have some high quality ones and stuff like that, then people can solve the problem with whatever tools they want. It's the Apache way, right? Why, it's the Hadoop way. Why solve the problem with one tool when you can have 4 tools which are all do it better, right? So I think that Zookeeper has served us a long time. Personally, I would like to see something in process. One of the things that Ryan brought up is there's just too many parts in here. I can't tell you the amount of times I've heard this story. Oh, my HBase cluster got wedged. I can't start it up again. So I just deleted all the data out of Zookeeper, and now it starts up just fine.
Or maybe it doesn't actually start up anymore at all.
Or maybe it starts up and some of the regions don't come up. And I think this goes to the fact of the people who run these systems are just so sophisticated, and that's fine. That's where all these systems start. When I was coding on an Apple IIe as a kid, the complexity of those systems was huge. Wozniak had to write the first version of Apple DOS in what was it 8K for an entire BASIC interpreter and operating system or something crazy like that. These systems are becoming more complicated as we add more functionality, but it's important that we often take a step back and say, hey, how do we make it more pluggable? How do we make it easier to run that type of stuff? So
has there been anything other than Zookeeper that actually works?
Yeah, so that's a really good question.
The big problem right now is that you can't, HBase is so wedded to Zookeeper that it's impossible to work on anything else. But is there other things that work like Zookeeper or is good? Stuff's getting there. There's etcd from those Docker guys. I think the Raft paper really triggered a new era in writing distributed systems, and we're going to see a ton of things in the next few years, ridiculous amount.
WANdisco sells a product based on a technology called Decode, which is in my opinion, light years ahead of all this stuff. I guess the one down part is it's not Apache licensed, but you know, yeah, there's definitely stuff that's better. And you know, Zookeeper is kind of like the jack of all trades for distributed systems, right? It supports all these APIs, does a lot of different stuff. But when push comes to shove, oftentimes you just want to solve a really specific problem. So if you can solve that with a specific program that doesn't have an external dependency, right? It's just like a library. Yeah, I mean that's way better, right? Because now your ops guy doesn't have to keep the Zookeeper up.
So I think there's a raffle thing.
Oh yeah.
Should probably do the raffle thing, you know. So
Yeah. See who wins.
all right. So how are we gonna rock this thing out?
Just pull a name and must be present to win.
All right. If you people who